May 17th, 2026. These are the most important stories since yesterday. In medicine, researchers found a small molecule that disables the MYC cancer protein's hidden DNA repair function while leaving its normal roles in healthy tissue intact, a therapeutic window that the field has treated as unreachable for 40 years. In science, seafloor seismometers at a Pacific transform fault have mapped the fluid-saturated fractured zones that physically cap how large earthquakes can grow, and those natural breaks are now identifiable from standard geophysical surveys. In tech, when Fisker went bankrupt and stranded 11,000 electric SUV owners, volunteers reverse-engineered the car's software, stood up a community parts supply, and launched flying doctors' mobile repair crews to keep the vehicles alive. In arts, someone posted a genuine Monet Water Lilies painting on X, labeled it AI-generated, and asked for critiques. Hundreds obliged, confidently citing the brushwork, color choices, and composition as proof of artificial origin. In labor, a peer-reviewed study from 3 universities found AI resume screeners pick candidates whose resumes were written by the same model 23 to 60% more often than equally qualified humans with human-written resumes. Deeper dives on all of this are in today's Century Report, and many are discussed further in today's podcast. Links to both are in the description. Or if you're already here on the podcast, let's get into it now. The MYC protein is one of those names that means nothing to most people but everything to oncology. About half of all human cancers overexpress it. It drives tumor growth, and for 40 years it has been one of the most studied and most defeated targets in cancer biology because every attempt to drug it directly ran into the same wall. MYC also does important work in healthy cells, so hitting it broadly poisons the patient. A team at Oregon Health and Science University just published something in Genes and Development that reopens the door. They found that MYC has been doing a second job nobody had cleanly mapped. Inside cancer cells, the protein physically helps repair the DNA damage that chemotherapy and radiation inflict to kill tumors in the first place. That repair role is biochemically separable from its day job as a transcription factor. 2 different jobs, 2 different molecular interfaces, and a small molecule compound that binds to one interface without touching the other. In cell models of MYC-driven cancers, the compound made tumor cells dramatically more vulnerable to the chemotherapy and radiation that they had been silently surviving. Healthy cells, which depend less on MYC for repair, kept working on the same dose. So let's be careful about how this lands, though. This is a paper. Cell model demonstrations are how the path begins. Animal studies, human trials, manufacturing, and regulatory review will take a long time. And access to a treatment is still some years away, most likely. But what changes here is that the assumption underneath the last 4 decades of work no longer holds. For 40 years, the field treated MYC as one thing and concluded that the one thing could not be drugged. But the OHSU paper shows the one thing was always 2 things, and one of them can be touched without disturbing the other. So that means the therapeutic window that the field has spent these 40 years describing as unreachable turns out to have been a measurement problem. So once the protein was resolved at high enough detail to see the separable jobs, the window appeared. The pattern is bigger than MYC, too. KRAS, another protein oncology had treated as pharmacologically unreachable since the 1980s, gave way recently when a clinical trial extended survival in pancreatic cancer patients after researchers worked out which specific mutant functions that the protein was running. The list of undruggable proteins is getting shorter as the resolution at which proteins are being read catches up to the complexity that was always there. So if you or someone you love has ever sat across from an oncologist and heard, "We don't have a good drug for this kind of your cancer," then the trajectory just got measurably steeper. Now the treatment room is still years away, but the year you do hear something different just got closer. All right, let's shift away. Different domain entirely, different paper, different problem, but the same underlying shape. Researchers at the University of Maryland, the National University of Singapore, and Ohio State published a peer-reviewed study this week measuring something a lot of people had suspected and nobody had pinned down. When a large language model is used to write a resume, and the same model is then used to screen the applicant pool, the model picks the candidate whose resume it generated between 23 and 60% more often than equivalently qualified applicants whose resumes came from human or from different models. The effect held across GPT-4, Claude, and Gemini variants. It survived controls where human raters confirmed the resumes were of comparable quality. The mechanism the authors proposed is stylistic. Each model produces characteristic phrasing patterns when drafting, and the same model's evaluator step recognizes those patterns as fluent and well-structured and ranks them higher. The candidate does not have to game the system. The advantage is automatic. Whoever happened to use the same vendor's tool that the employer happened to deploy gets the boost. Nobody decided that this should happen. Nobody is reaching for it. The loop closed when nobody was watching the wiring. So if you're job hunting, that's the immediate consequence, but it's solvable on your side within months. Consumer resume tools that optimize across the major models do already exist, but that's just the surface. The deeper layer is what the study implies about every other place that this kind of closed loop is operating. Grant applications, college admissions essays, regulatory filings, internal performance reviews. Any setting where a model's written output is judged by a language model and the person produced that output with a language model has the same vulnerability. Across academic peer review, the pattern is already documented. Berkeley and UC Santa Cruz researchers found frontier models inflating reliability scores for AI peer outputs that matched their own. The running record on this ARC lives on the ARCs tracker on the website if you'd like to check it out. The hiring study is the same phenomenon arriving on a new surface, one with shorter feedback loops and more legible stakes. So let's take this further. The evaluation architecture that companies, universities, journals, and HR departments have been building on top of LLM screening for the last couple of years now had a structural assumption underneath it, that the thing being judged and the thing doing the judging were independent. And that assumption is now characterized in peer review and quantified, reproduced across 3 commercial models. The number is on the page, and it's between 23 and 60%, which is the kind of number a hiring manager can read in one sentence and act on. So there's corrective work to be done here. Running heterogeneous evaluator ensembles, normalizing language with blind paraphrase passes, putting humans at decision boundaries is already prototyped in HR tech and admissions research labs. The SHU paper is the precondition for the fix. What it dissolves on its way out is the captured advantage of being early on a particular vendor's tooling. Being first to deploy a specific model's screening was a position only as long as the bias was invisible, and now it has a citation attached to it. The candidate who was losing places that they were qualified for without knowing why has a paper now to push back with. All right, shifting away again, I want to tell you about something that should not, by the logic of how the car industry has worked for the last 15 years, exist. In June 2024, the EV maker Fisker filed for bankruptcy. About 11,000 Ocean SUVs had already been delivered to buyers, and in the modern category of software-defined vehicles, those buyers were holding objects that were supposed to slowly die. The over-the-air updates servers belonged to a company that no longer existed. The diagnostic tools, the mobile app, the parts pipeline, the key fob pairing software, all of it lived on infrastructure controlled by Fisker. Lose the company, lose the cars. That is how the architecture was built. Electrek published a long piece this week on what actually happened, though. The Fisker Owners Association, now roughly 4,000 members, spent the months after the bankruptcy rebuilding nearly every function the company used to provide. One member published a multi-part series mapping the Ocean's internal CAN bus protocol packet by packet. A developer under the handle Michael OE built an unofficial API and connected it to Home Assistant, giving owners back the remote monitoring features that the dead app could not deliver. Bulk parts buys organized by the association brought the price of a replacement key fob from roughly $1,000 to a fraction of that. A volunteer network of mechanically inclined owners, they call themselves the Flying Doctors, travels now to help members with repairs that the dealer network would never have shown up for. The cars are still on the road. The fleet is small, and the technical lift has been heavy, and nobody is pretending that this is what the average car owner should be expected to do, but the demonstration is now on the record. Cory Doctorow wrote about it as a proof that software-defined vehicles need open architectures by default. Vitalik Buterin pointed to it as evidence that automotive open source has shifted from hobbyist preference to consumer protection requirement. Both readings point to the same observation. The assumption that the auto industry has operated on for the last decade, that the proprietary control of a vehicle's software stack is the only viable form, and that owners are tenants of their own cars at the manufacturer's pleasure, had its central claim tested here. The claim was that owners could not replace the manufacturer if the manufacturer went away. That claim is now visibly wrong. So if you've ever bought a car that came with a phone app, a subscription, an over-the-air update channel, a feature that could be disabled remotely, you bought it on the premise that the company would always be there. The Fisker owners were the first cohort to publicly demonstrate what happens when that premise breaks and the customers refuse to be stranded. Now, a reasonable read of this is that the next consumer protection floor in this category is being written in real working code on a Discord server somewhere before it is written in legislation. A regulatory environment that requires CAN bus documentation, parts supply continuity, key pairing tooling, and diagnostic access to be releasable when a manufacturer fails, the way airworthiness data has to survive an aircraft maker's bankruptcy, would, on the evidence of this story, work. The volunteer infrastructure that proved the model exists already. The remaining work is making sure that the next 11,000 owners do not have to depend on the goodwill of one packet mapping engineer. Now, this is a question that we're all going to be facing a lot more often very soon as companies continue to rise and fall in the age of AI, and we have to deal with the at best fluid availability of their proprietary software. This is a great example of why open source software is increasingly important as we move forward in the age of AI. Last story for today. This one is about how we see and about bias. Someone posted an image on X, Claude Monet, an authentic one of the late Water Lilies canvases, painted at Giverny, hanging in a major museum, documented for more than a century. They captioned it, "AI generated, what do you think?" The replies ran into the hundreds, and here is the part to really focus on. People did not just guess, they explained, confidently. The brushwork is too uniform, the color transitions too smooth, the compositions lacked the asymmetric tension that a real painter would have introduced. The reflections in the water were obviously a diffusion model trained on impressionist source material. A handful of people recognized the painting and did say so, but many of the people who had called it AI pushed back even after they were corrected. So let's stay on the shape of this for a second. A century of art history says Monet's late water lilies are among the most technically accomplished oil paintings ever made. The exact qualities that people pointed to as proof of a machine, the smoothness, the uniformity, the lack of tension, are descriptions of the actual painting. The same brushwork that put Monet in every museum on Earth now reads, to a lot of educated viewers, as the fingerprint of a machine. Now, this pattern has run before in the other direction. When photography arrived, paintings were praised for being photographic, as a compliment. But once photography stopped being novel, the same paintings were criticized for the same quality. The criteria for what counts as real artistry moved to wherever the line between human and machine sits in a given decade, and increasingly a given year and given month and given week and given day. The line moves, and the criteria follows it. What is genuinely new here is the speed. A 100-plus-year-old painting in a museum can now be confidently misread as a generated image by people who look at art for a living, because their working model of what a machine makes has absorbed so much of the real world that the real world reads back as the machine. We covered the audio version of this in April. Deezer reported 97% of listeners could not tell AI-generated music from human-made tracks. Same merger arriving in sound and now reaching back into a canvas painted before anyone listening was born. The aesthetic vocabulary that people use to talk about pictures reorganized itself around generative systems in about 2 years. If you have ever been sure that you could tell that there is some giveaway your trained eye catches that a machine cannot fake, a museum-grade Monet just walked a few hundred confident people right past that certainty. The line between what a person can make and what a system can make has already moved. What is still sharp, though, is how much energy goes into redrawing it, and how often the qualities that people reach for to redraw it turn out to be the qualities of the masterpieces. And of course, there are all sorts of questions this raises about the viability of art and the difference between human-made art and machine-made art. Questions that I think are collapsing more and more as time goes on and we move forward in this new era. All right, let's close out for today. 4 different problems that people had told themselves were structural. A cancer protein that the field had treated as one thing for 40 years turned out to be 2 things, and the wall that everyone had been pounding on was a wall around the wrong question. The peer-reviewed measurement of a closed loop inside AI hiring tools turned a piece of vendor-locked optimization into a citable bias that the next round of screening will have to be designed to correct. 4,000 car owners reverse-engineered a bankrupt manufacturer's proprietary stack and proved the lock that was supposed to brick their vehicles wasn't holding anything. And a 100-year-old Monet, posted as a machine's work, drew hundreds of confident people explaining a museum masterpiece's brushwork as the fingerprint of a diffusion model. The line between what a person makes and what a system makes already moved, while the people most certain they could see it were pointing to the wrong side. This is a phase transition. The substrate underneath each of these stories was finishing while nobody was watching the headline. The protein structural databases, the peer-reviewed evaluation literature, the open-source automotive tooling and CAN bus reverse engineering, the generative image culture that has saturated how a trained eye now reads a canvas. The moment a problem landed on each substrate, the response architecture was already there. If you've ever heard a doctor describe a category of disease as untreatable, the assumption underneath that sentence is being tested at a rate the prior generation of medicine could not have predicted, let alone produced. If you've ever had a job application disappear into an inbox that you suspected wasn't reading you fairly, the bias just got named and measured, and the regime that depended on it staying invisible is now on the clock. If you've ever bought a piece of hardware that came with the implicit promise that the company would always be there to keep it running, the cohort that proved otherwise just published the playbook. And if you've ever been confident that you could spot the machine's hand in a picture, a Monet just walked a few hundred experts past that confidence because the reference for what a machine makes has absorbed the real world. The walls people have been telling themselves were permanent are being measured at a higher resolution this year than last. Some of them aren't even walls. What is being built underneath each one, by labs, by auditors, by owners, by a visual culture rereading its own canon, is the substrate that lets the next problem be approached at a depth we were previously blind to. Now tonight, when you put today down, the world is one report closer to what it is becoming. We'll see you tomorrow.